Hello and welcome to Algebra 2, Lesson 3.2 on substitution and elimination. Let's take a look at what we're going to be doing for today. First of all, Lesson 3.2 is over solving systems of linear inequations. Now, we've been graphing linear inequations, and we know that when we graph those on a coordinate plane, in some cases, if we get lucky, they may intersect at two whole numbers, and we can look at those and say, hey, these two lines cross at, for example, the 0.12 or the 0.67, and we can see that, and we can go on the table and find it and see that we're correct. But in a lot of cases, when we graph two lines, they may not cross perfectly at two whole numbers. And in this case, we need another way to find where they cross each other. And we're going to use two different methods today. One being substitution, and the other being elimination, to find what we know as an exact answer. Because when we graph those, in some cases we have to guess or we have to approximate a solution. And in some cases, if they want an approximate solution, that would be fine. But if we're looking for exact answers, substitution and elimination is what we're going to be using today. Let's start with substitution. We've got two different examples we're going to be doing today using, first of all, the substitution method. Now, we have substituted numbers in for variables, so we know what that means. The substitution method is very similar to that. When we're doing substitution, a couple things that I like to look for. When I get my system, the first thing I like to look for is there an x or a y variable that has a coefficient of 1? Meaning, is there an x or y variable that's kind of by itself? As we are looking at this particular equation, you can see that the top equation up here, and that is the 2x plus y equals 9, is by itself. The y is by itself there. So that would be the equation that I focused on. So we're going to start by taking a look at this top equation of 2x plus y equals 9. And again, because the y is by itself in that one. The reason why I chose that equation, first of all, is when I copy this down, it's very easy for me to get the y by itself. All I have to do is subtract 2x from both sides. When I do that, I get an equation of y equals negative 2x plus 9. Now that I know what y equals, which is this quantity right here, I'm going to take that quantity and I am actually going to plug that quantity into the second equation, or see my y. So that entire quantity of negative 2x plus 9 is going to get substituted in for the y in the second equation. And when I do that, here's what I would have. I would have 3x minus 4, and now here comes that quantity, times the quantity negative 2x plus 9, and then equals 8. Okay, here I see I have the distributive property I need to take care of. So when I do that, I'm going to end up with 3x plus 8x when I distribute here. And then minus 36 when I distribute here, equal to 8. I can see here that I can combine my like terms of 3x and 8x to get 11x. Minus 36 equals 8. Now I can add 36 to both sides. And I'm going to end up with 11x equal to 44. Divide by 11. and find out that x equals 4. Now I've solved for x. Okay, now that I know what x is, all I have to do now is find y. So we'll keep that x equals 4. Let me get some room here to show you the rest of what I'm going to be doing next. So as we find our x value, ultimately our final goal then would be to find y. I'm going to leave my x equals at the bottom of the screen here so that we remember that that's what x is. And now thinking, if I know x, can't I just take this x and go ahead and just plug it into one of my two equations? Let's say the top one. Put that in for x. Yeah, if we do that, here's what we're going to have. 2 times x, which we now know is 4, plus y equal to 9. And now we've got 8 plus y equal to 9. Last step, I want to subtract 8 from both sides. And as you can see, we now know what y is. Y is 1. X is 4 and y is 1. That tells me that we have a solution at 4, 1. That is a solution to this system of equations using substitution. These two lines, when graphed, cross at 4, 1. If I want to, remember, this is my x and this is my y, I could plug these two in for x and y just to check and see if it equals 9. And plug it in for x and y just to check and see if it equals 8. Just to check and be sure that those two are correct. And when you substitute those back in, you'd find that they are. Now we're going to use the same method for example number 2 over here. Example 2, as I look at it, again, the first thing I want to look for is there an x or y by itself? In this case, I notice that there's an x right here by itself. Therefore, I'm going to take that top equation and simply solve it for x. This is an easy step. So let me recopy x minus 9y equal to 25. And just show you that all I have to do is add 9y to both sides. So this gives me x equals 9y plus 25. There's what x equals. Okay, I'm going to be using this to now go to the second equation. Plug it in right here for x. When I do that, let's see what we've got. Remember, when we plug it in, we are plugging in this entire quantity for x, because that's what x equals. So now we have 6 times x, which is this entire quantity, 9y plus 25, minus 5y, because that's right here, equals 3. So we've plugged the 9y plus 25 in for x, and here's our new equation. Obviously, we've got a distributive property here and here that we need to take care of. And that's going to end up giving me 54y plus 150 minus 5y equals 3. Okay, now that I've got this, I see I can combine a couple like terms on the left side. 54 minus 54y minus 5y gives me 49y plus my 150 equal to 3. I'm going to subtract my 150 from both sides. And now I've got 49y equal to a negative 147. Last step, let's divide by 49 so that we now know what y equals. And when you divide this out, you end up with a negative 3. There's my y equals. I found my y value. Okay, at this point, it's very similar to the last one we did. The last one, though, we found out that y was 1 first, and we plugged it back in and found out what we were going to get. Now, we find out that y equals -3. Since I know what y equals, keep this in mind. Once I know y, I can plug y back into this equation for y, or I can plug it into this equation for y. Either equation will give me the same answer for x, because remember, this is a system of equations that we're looking at. It's where they cross each other. So, let's take a look at where we're going to plug this in. First of all, I'm going to keep my y equal to -3. I'm going to get rid of my work here, so I have some room to show you what we're going to do next. All right, so keeping my y equal to -3, let's decide where we want to plug this in. All right, so I'm going to go ahead and take this -3, and how about we just say, let's just plug it into this bottom equation. Let's plug it in right here. So that's going to give us 6x minus 5 times my -3 equals 3. That's 6x plus 15 equals 3. I'm going to subtract my 15 from both sides. 6x equals -12 and divide by 6. X is going to equal -2. There's my other answer. I now know my x. I now know my y. I can go ahead and write a solution for this thing. These two cross at -2, -3. And once again, we've got a solution for our system of equations that if we wanted, we could plug in our x and our y values back into these equations up top and check to see that this one equals 25 and that one equals 3. And when you do, you would find out that they do. That is how to use substitution. As we go back and take a look at both of these systems that we have set up for you, I do want to mention a couple of things. First of all, in each of these systems, as you can see, the way that they're set up, in the first one, the 2x plus y equals 9, and that is this top equation. The y, in that case, was by itself. In the second one, the x minus 9y equals 25, the x was by itself, meaning it was really easy for this one and for this one to get the y, in this case, and the x, in this case, by itself. Now, the question is, what if you don't have an equation where x or where y is by itself? How would I solve something that looked like that? Well, if that happened, then you would just simply have to decide which one of these two would you want to use. For example, if I had, and I'm just going to write this out, if I had 2x plus 3y set equal to 7, and 4x minus 6y set equal to 9. Here's a system. What would I do with this because I don't have any x's or y by itself? Well, I might just decide with this top one, I want to go ahead and just solve it for y. Or you can solve it for x. It doesn't matter. You decide. But if I wanted to solve that for y, basically get y by itself. And yes, you will have some fractions involved there. Since I got y by itself for that top one, I would also want to get y by itself for this bottom one. And then we would end up with two equations that are both y equals. When that happens, whatever quantities you have on the other side of the equal sign, all you have to do is take those two quantities and set them equal to each other. And then you can use those to simply solve for your x and your y. In this case, since we have y equals on both of those, we would be solving for x, because what would be left inside of here and inside of here would only be the variables for x. So when we were done, we would have what x equals. And then, as we did before, whatever that x value is, we would take it and plug it back in to one of these two equations to find our y. So there's an example of what would happen if you don't have an x or a y by itself from the beginning. Okay, next up is the elimination method. This is going to be, again, another method that you can use to find the solution to the system of equations. Now, this one's a little bit different than substitution, and you might find this to be the one that you like to do. Again, it'll be your choice, whichever one you choose to do, but you will need to know both. Let's take a look at the elimination method. The elimination method is exactly what it sounds like. You are going to try to find a mathematical way to eliminate one of the two variables, whether it be x or whether it be y. Now, in some cases, your neighbor may eliminate the x while you're eliminating the y. It's all a matter of preference. So let's take a look at this first system. This very first system that I'm seeing up top here, that's this one. One thing that I notice right away is in the bottom equation, obviously this would be 1, I have 1x. And in the top equation, I have negative 2x. Now, here's what I want you to think about. If I would be able to mathematically multiply this 1x by a positive 2, then it would become 2x. And if I combine the negative 2x up top and the positive 2x below, they would actually cancel each other out. Well, you're actually mathematically able to do this. And here's what I mean by that. Let's take this first equation that I'm pointing at here, the 1x minus 3y equals negative 3. And let's say that we multiply that entire equation by 2. So again, let me just show you. We're going to take that entire equation, 1x minus 3y equals negative 3. And we're going to multiply it by 2. Basically, we're going to distribute the 2 on every part of that equation. When we do that, here's what we get. 2x minus 6y equals negative 6. And again, just for a visual, so you're following along, we're just distributing this on all three parts. And now we've got a brand new equation of 2x minus 6y equals negative 6. Now, that new equation which we just created is equal to the original. It's the same thing. We just multiplied it by 2. Here's why that's going to be helpful. Let's take a look at this top equation that we've done nothing with at this point. Let's go ahead and just recopy it back into the system. It's negative 2x plus 7y equals 10. And now, here's what elimination is. You can now take this entire system and say, hey, we want to add these two systems together because we can combine the like terms. And when you combine the 2x minus the 2x, they cancel out and become 0. Negative 6y plus 7y leaves you 1y. And negative 6 plus 10 leaves you 4. And notice we just found out what y equals already by a process we call elimination. Once I know what y equals, keep in mind, we can take that y value and plug it into the first equation or the second equation, your choice. Let's take a look at plugging that value into the top equation. So when I rewrite my negative 2x, that's my top equation, plus 7, and now we know what y equals, so we're plugging that 4 in for our y, so it's 7 times 4 equals 10. Now we get negative 2x plus 28 equals 10. I'm going to subtract my 28 to both sides. And now I've got negative 2x equal to negative 18. And now the last step would be to divide by my negative 2. That would leave me with x being equal to 9. I already have my y, I now have my x. Yep, you guessed it, that means we've just found the system of equations solution. It's 9, comma, 4. Using elimination, we found the system of equations solution, and that is 9, 4. Again, you can plug those back in for x and y to check, and you would see that that is the solution. All right, let's try this again with the second equation. So if I go ahead and give myself some room. Okay, let's take a look at this one. Again, we're trying to eliminate either the x's or the y's. And again, it really doesn't matter which variable you eliminate first. I like to look at the x's and y's and say to myself, which one would be easier to eliminate? So in this first problem, you'll notice that we eliminated the x's. So just to do something different, in this problem, I'm going to eliminate the y's. Now, I will tell you, looking at this, I think eliminating the x's are probably easier. But again, just to make it different, I'm going to do the y's for you. So I'm looking at just the y values. And the y values in this case, we've got an 11y and a negative 6y. So I'm trying to figure, is there a number that both of those go into evenly? And really, the only number we come up with is 66. And the easy way to find that is by simply multiplying those two together. That's the first one, they go in evenly. So here's what that tells me. If I'm going to do this problem and eliminate the y's, the first thing I'm going to do is I'm going to take this top equation and I'm going to multiply it by a negative 6. Then I'm going to take this bottom equation and I'm going to multiply it by, that's going to give me, notice, that's going to give me a negative 66y. And so if that's the case, I would multiply this bottom one. I want this to become positive 66y. So I'd multiply it by a negative 11. Now, I could have chose to multiply the top one by a positive 6, which would have gave us 66y, and then the bottom by a positive 11, which would have gave us a negative 66y. Either way, you want those to cancel out. So you choose the signs that you want to use and multiply them. So when we do that, let's go with the top equation first. We're going to multiply the top equation by negative 6. That's going to give us negative 18x minus 66y equal to negative 24. The bottom one, multiplying it by negative 11, it's going to give me 22x plus 66y, which is what we want, equal to 0. Now we're going to do our elimination method. We're going to say, hey, let's add these two equations together. So we got negative 18x and 22x. That gives me a positive 4x. The 66y and negative 66y cancels. And I'm left with negative 24 on the other side. As you can see, this is a little bit quicker than substitution. I'm going to divide by 4. And that leaves me with x being equal to negative 6. I already found my solution for x. Again, this is where I can take that solution and plug it into the first equation, which is on the bottom, or the second equation, I'm calling it on the top. Doesn't matter. Let's go with the top equation. I'm going to plug negative 6 in for x. So the top equation, that would be 3 times my negative 6, because that's where the x is, plus 11y equal to 4. That gives me negative 18 plus 11y, set equal to 4. I'm going to add 18 to both sides. 11y now equals, and on the right side of the equation, I've got a positive 18 and 4, which gives me 22. And now my last step is to divide by 11. And I get y equals 2. Got my x, got my y. We have our solution. It's the point negative 6, 2. Not negative 2, sorry. So, again, given my solution, negative 6, positive 2, I can plug those back into the system of equations to check to see that I'm correct. And that is the elimination process.